Welcome to the Middleware Tech YouTube channel. In this series, you'll learn about Java buzzwords. All code examples used in the videos will be available on GitHub. Let's get started.
Buzzwords means if I'm say today Java, see lots of languages there. I will say Java is there, C++ is there, .NET is there, now Python is also there. So lots of languages there. Now, when I say buzzwords, what does it mean by this? Buzzwords means how I can separate a particular language from some other language based on some important technical terms. That is called buzzwords. Okay, so that is buzzwords, some important technical terms about a particular language. Okay, that is called buzzwords. So if I say buzzwords for Java, then we have to say some of the points like some words like we can say object oriented. This is one of the buzzwords, object oriented. Then you can say distributed. And distributed. We have another word, another one point like multi-threaded. Multi-threaded. These are some buzzwords related to Java. Number 4, you can say simple. Let's go with some technical terms like platform independent. Platform independent. You can add another 1.5. You can use secure. Okay, so I've just written here some other point is there as a simple, you can say. So these are some of the words. These are called buzzwords related to Java. If I say Java language, so then these some of the points come into picture. I'm coming into elaborate discussion about all of them one by one. Right. Okay. So this Java programming language, it's an object-oriented programming language because one of the main goals of Java technology programmer is to create object. That is some autonomous code that can interact with other object to solve some problem. But this object-oriented concept that came long back. Okay, this concept started with a particular language. Its name is Simula 67 programming language that came in the year 1967. So this object-oriented concept came long back, and after that you find that object-oriented concept with programming language called C++, and then it came in Java after the right. So let's talk about these buzzwords in details, step by step. Some discussion we'll do these buzzwords. Okay, so let's take one of the words called object-oriented. Control C, object-oriented. Let's give some introduction on this first, then I'll come. So first I'm talking about one of the buzzwords called object-oriented. Okay, so what does it mean by object-oriented? If I'm saying object-oriented, what does it mean by this? Let's understand this one first. Okay, let's understand this term object-oriented. What does it mean? This is the first point. I say that okay, it's an buzzwords. Fine. What does it mean by these buzzwords? Okay. Let's see how I can define an object. Object is defined like how I can going to define a particular object. Object means anything that we can for anything that we find in real life can be defined as an object. Okay, if I have to say that how we are going to define an object. So anything that we can find in real life can be defined as an object. You can see a car, so car is an object. You can see a chair, chair is an object. You can see a laptop, laptop is an object. Building, building is an object. So object means anything that we can anything that is that you can see in real life that can be defined as an object. In layman's language, you can say, right, like, so anything we see can be defined as an object. Fine, first point I've given. So assume anything means what? I can see a particular car, so car I can say a particular object. I can see a pen, so pen I can define as an object. I can see a chair, chair I can define as an object, right? So whatever things I can see, I can define as an object. Fine. So let's take any one of them. Assume I'm taking pen. I'm saying pen, it's an object. Object. It's an object. Object. Fine. So if I say pen is an object, so for pen, for any object, you'll find two things. For any object, you'll find two things. One is called attribute. Attribute. Another is called action. Action. So for any object, you'll find two things, attribute and action. So I've just taken here pen object. So pen object, you'll find two things, attribute and action. So what is the attribute for pen object? Assume color. Color. Or you can define, let me write it in lowercase, color. I have written one attribute. Pick length. Length is an attribute of a particular pen object. Or brand name. Brand name. Attribute is something that has some value. Brand name. Brand name. Fine. Or cost. Cost. Right? So these are the attribute that has some value. Attribute for a particular pen object we can define. Right? So what is the action for a particular pen object? Any action, take any action. Why? What is the use of this pen object? I'm using this pen object to write. Write. So this is an action. These are the attribute. This is an action. So for a pen object, have some attribute and some action. So that how I can define a particular object, like object have attribute and action. So I can say another one point about an object, like object have attribute and action. Any object that you can define, for any object, you'll find an attribute and an action. So in this example, I have used pen object. So for pen object, I find some attribute that has some value and some action. Fine. Okay. So in object-oriented programming, I've showed when I say object-oriented programming or OOPS, This OOPs, these OOPs have some features like using object oriented, it support the concept of modularity, then can hide some information, it can reuse some code. We'll talk about all those step by step. For the timing, just I've given what does it mean by object oriented. Java support the concept of object. So object that has some attribute and action. So like this way you can define multiple object, and multiple object will interact with each other and complete some task. Multiple object will interact with each other and complete some task. How it is? You can see multiple object. When I say object oriented, multiple object will interact with each other and complete some task. It supports some of the concept like modularity, means that the source code of a particular object can be retained and maintained independently, the source code for other object. So after it is created, an object can be easily passed around inside the system. We can implement some information hiding also using object. Okay, so because by interacting only with this object's method, the details of its internal implementation remain hidden from the outside world. How I can hide the information, I'm coming into that. Or we can do some code reuse also. If an object already exists, you can use that object in your program. So that is nothing but one type of reusability we can implement using an object, right? Okay, right? Okay. Now here, that I'm talking about this object-oriented. First point, object-oriented. Given one of the buzzwords. This is the idea. I'm coming into depth after some time. Let me give some point about each of them. Then another point is distributed. Next buzzwords. I'm talking about the next buzzwords. Control C. Next buzzwords. Or if you want to say next buzzwords, I'm talking about distributed. So it is another one buzzwords. This is distributed is another one buzzwords in Java. What does it mean by distributed? Let's spend some time on distributed. It's a very important technical term because our complete enterprise level application is running based on this technical term, distributed. I'm saying from layman's language, just understand it. Step by step, so we'll move with in depth. See, distributed, what does it mean by this? Distributed. Distributed means remotely call some function. What does it mean by this? Remotely call some function. What does it mean by this remotely call some function? See here. Let me give one example just to understand the concept of distributed. Then I'm coming to the actual meaning. Now assume this is a it is an assume this is an Air India. Assume, I'm just giving an example to understand it. Air India has their website, and Air India website is running inside a server 1. Their website is running inside server 1. Now if I want to buy an Air India ticket, from one location to another location, I can go to their server, their website, and I can buy the ticket. Fine. Assume we have another one, Air Asia. Their application is also running inside a server. Assume it's server 2. If I want to buy a ticket from one location to another location, I can go to this Air Asia website and can buy the ticket. But generally we don't go to their website most of the scenario. Where we go, either we go to Make My Trip or Clear Trip or Go Bibo, this type of website where we'll get all the flight details in the single location. All the flight details is available in the same location or in the same site. Multiple flight details is available. So assume I'm just writing Make My Trip, and their application is running inside a server. Their server, assume it is server 3. So this Make My Trip is a portal type application where this vendor and this vendor has some agreement. Based on the agreement, Air India flight details is available to Make My Trip server. Assume after 1 minute or 1.5 minutes, based on the agreement, all the flight details of Air India gets updated inside the Make My Trip portal automatically based on some services. Similarly, all the details of Air Asia server gets updated in the Make My Trip portal server based on some agreement. After 1 minute, 1.5 minutes, it gets updated. So if I'm going to buy any ticket, airline ticket from Make My Trip server, then I can get all the flight details in the same website. So this is how, like this way, you can add multiple other airlines also. Now, what does it mean distributed? I'm talking about the meaning of distributed. I've just written here, distributed means remotely call some functionality. What does it mean by this? Right? Assume. So what does it mean by this? See, when you are going to execute a Java program, the Java program run above JVM, Java Virtual Machine. I'll talk about after some time. JVM. JVM full name is Java Virtual Machine. When you install the JDK in your system, then that JVM, when you're going to execute any Java program, when you're going to run any Java program, that will run above JVM. I'll talk about JVM in details after some time. Now this application is Java program is running, that is also running above JVM. Assume this is also Java application, so this is also running above JVM. Right? Now see here, this is a server, this is a server. So this server is a client to this server, and these two servers is exchanging data. This two server is exchanging data. Right? So that means one server is a client to another server. One server is a client to another server, where the code is calling, or the functionality is calling from one JVM to another JVM. So when I'm going to call a particular function from one JVM to another JVM, that is nothing but distributed. I'm saying another meaning of distributed. Distributed means call function from one JVM to another JVM. This is the meaning of distributed calling. Sometimes we say that remotely calling some function is called distributed. If it is not clear, I can say this one, the timing, it will be much more clear. Remotely calling some function from one JVM to another JVM is called distributed, and that we can implement this distributed functionality supported by Java, and we can implement these distributed features with some of the application component. We implement distributed features using some application component like EJB, ADF, BC, BC4J. These are some of the Java-based application component we used. Now, if you find some doubts here, so just see here. Let me show you one. What does it mean, application component? What does it web component? If you find some doubt here, let's just see here. Just see. See, let me give some introduction. When we talk about any J2E application, web application, how web application work in Java J2E environment, I'm going to give you some idea. Three-tier architecture web application. So three-tier architecture of Java or J2E application. Just idea, because it will help us to understand the concept of distributed. So just see here how a simple J2E architecture work. Assume you want to create a banking application that is based on three-tier architecture, and create a particular shopping application, or you want to create a particular healthcare application. Okay, right. So any Java J2E application, they generally follow three-tier architecture. So the client here we have middle tier, okay, and we have EIS tier. Client tier means with client tier means I'm going to interact with the Facebook page, Yahoo page, Gmail page. So that is client tier. As a client, I'm going to interact with a particular page. So that is this client tier generally implemented as .html or .jsp or .xml page is also there. And where you're going to use some of the advanced framework like AngularJS, Node.js, React.js. So lots of advanced framework you can implement in the client tier. Now in the middle tier, we have we can divide the middle tier into two parts: web tier, another is application tier. Right. So web tier means sometimes we say web container. So web tier is used. Middle tier is a server. It's a server. So that server you can divide into two category of server: web server and application server. So you can say web server and application server. So web server, as per example, web server like already you know some web server example. Like Tomcat is one example of web server, or Apache is another example of web server, right? In the web container. Whereas in the application server, in the middle tier, we have application server also. Some examples of application server like, tell me, like JBoss from Red Hat. We have IBM WebSphere, right? We have some of the other application server like Oracle WebLogic application server. This is the application server. Fine. Okay. Now, this web server is used to execute some web component. It is used to execute some web component. Examples of web component like it is used to execute some web component. Right? Web component. It is used to web server is used to execute some web component. Examples of web component like servlet, JSP, right? Okay. Whereas application server is used to execute some application component. You used to execute some application component. Examples of application component like EJB, ADF BC. EJB full name is Enterprise Java Win. ADF-BC full name, it is a framework from Sun Microsystem. ADF-BC full name is Application Development Framework Business Component. It is from Oracle ADF framework. We can use BC4J also. BC4J, it is another application component. Full name is Business Component for Java. This is another application component that is used in Oracle ERP. Next, we have another application component called Spring BC, Spring Business Component. So these are some of the application component that is executed inside an application container. They're the web component that is executed inside your web container. Right. Now, if I want to write on the other side, we have EISTR. EIS is a logical name. Full name is Enterprise Information System. It can point to some data source. So that data source may be a database. The data source may be any ERP applications like Oracle Apps or Microsoft Dynamics, Apache ERP is there, IBM also is there. So different ERP, or it may be a CRM application, or any particular JMS API, whatever it is, it's pointing to some data source. From where some data will come, it will consume, right, or return. Whatever it is going to point to some data source. Okay. So this is a three-tier architecture. How a basic JTE application work? Any JTE application generally follow this architecture. Now, if I want to write a business logic, this business logic, how I can write inside any logic I can write inside the client here. I'm going to write business logic in the client here. How generally we use JavaScript. If I want to write in a business logic in the web container, I can write the business logic using Java web component. If I want to write any business logic here, business logic, right? So I can use Java web component or Java code. Now here, if I want to write the business logic here, okay, business logic if I want to write here, so I have to use this application component to write business logic. We can use this this application component. We can use Control C to write business logic, right? If I want to write a business logic inside the EIS tier, I have to use PL/SQL in the database. Assume it is database. So I can write the business logic in the database. Using PL/SQL. So this is how a basic JT 3T architecture work. Fine. Now, if you see here you'll find two components. These are called web component. Okay, server JSP, these are called web component, and these are called application component. You can write your business logic using web component as well as application component both. Okay, so here there is two types of component is there. Just see here, please. There's two types of component is there. There's two types of component. One is called web component. Web component. What is the web component? Web component is this. These are called web component. Control C, Control V. Bean is also there, and we have some application component also. application component. Examples of application component are this. They're called application component. We have some other things also, Control Z, Control C. These are called application component. Fine. Now here, you can write the business logic using web component for a simple web application, right? So you can create you can write the business logic using this web component for simple web application. But if I'm going to write an enterprise level application, then I need this component. Enterprise level application, then I need this component, because for simple web application this component is okay, but for enterprise level application you need this component. Why? Because this support some of the features for enterprise level application. And I say that this, what is the enterprise level application? Enterprise level application is that application that is running worldwide. Assume many different vendors like LG Electronics, Honda, Vodafone, HP, Oracle, they're handling their operations throughout the world in multiple countries. So when that operation is running in multiple countries throughout the world, so that application is running in multiple servers, right? So when your application is running in multiple servers, then that have some features to handle, like it has to handle some of the features like distributed. I'm not going into the meaning for the time being now. Persistence, transaction, web service support, then we have load balancing. So lots of features is there. I'm not going to that. So these are the features are called, these are the features of enterprise level application. So we can implement these features using this application component, and these application components are Java based. See here. So one of the features is distributed. We are talking about this only, right? So to understand that distributed only, I've just have to say that much. So we are talking about that term distributed, right? So what is the, where it is? See, this is the thing we are talking about here. So we are talking about this distributed term. What is this distributed? Distributed is one of the feature buzzwords for Java. Fine, right? So this meaning is that calling a function from one JVM to another JVM, that is called distributed. Okay, fine. So how? Okay, fine. Now, how to call a particular function? So that is a separate topic that is called distributed environment communication. So distributed environment communication it can implement using RMI. We have another one. So if I'm coming into that, how to implement distributed environment communication? Distributed environment communication. To implement distributed environment communication, see, just now distributed is one of the features of application component. Just now I've given one example, right? From here what you find, it's the features of an application component. It's the features of an enterprise level application. So for enterprise level application, if I'm going to write some code, I need this application component. So these application components support these features. That means distributed is one of the features of your application component. Right. So that is you're talking about here. Right. So we can implement distributed features using some of the components. So this application component can, these are Java-based application component. Right. So using this Java-based application component, we can implement the features of distributed. Now, distributed environment communication is there. How we are going to call a particular function from one JVM to another JVM, so that is a part of distributed environment communication. So to implement this distributed environment communication, that means one server, it is one system, right? It is another system. One code is calling from one system to another system, one JVM to another JVM. So how it is going to call, So for this different technology is there, like first RMI came. RMI has some limit. RMI full name is remote method invocation. It has some limitations. So then CORBA came. I'm not going into those details. CORBA came, Common Object Request Book Architecture. This is also used to implement distributed environment communication. It has also some limitations. Then XML web service came, right? It has also some limitation. Then came to show lots of things there. Fine. So this is all about. I'm not going into that how to implement that distributed environment communication. Then you have to go with the session called XML web service session. Okay. Fine. So we are talking about the buzzwords distributed. That's why you have to talk this much. Just to talk about the buzzwords distributed, right? So it's a very, very important buzzwords of Java, right? So, right. Okay. Fine. So I've just told you only two buzzwords, right? One is object oriented just now. Given some idea about object oriented, I'm coming into details. Then talking about the buzzwords called distributed. Fine. Okay. So let's move with another one buzzwords called multi-threaded. Let's say some points. I'm not going to say much more here. Multi-threaded. Let's talk about another one buzzwords called multi-threaded. Because we have a separate thread chapter. Spent 4 to 6 hours full day on thread only. So that's why I'm chasing some points about this multi-threaded. Now see, what is multi-threaded? So multi-thread also you can say. So this Java programming language support the concept of multi-threading. So thread means what? Simultaneous execution of program. So that means multiple thread will work simultaneously and complete some task. Multiple thread will work simultaneously and complete some task. You can see one example here. That means this allow several. That means if you see this image, this allows several tasks to run concurrently. That means at the same time, such as you can say querying a particular database is going on one side, on the other side performing some long running process or some complex calculations, on the other side interacting with some GUI interface. So all the tasks that work simultaneously is nothing but the concept of thread. So when multiple thread will work simultaneously and complete some task, it has some advantage. How it is? Like 5%, 10 painter will take 1 day to paint a room, whereas one painter will take 10 days to paint the same room. That means when I implement multiple thread, then it will reduce time and all the tasks will work simultaneously. That is the concept of multi-threaded. I'm not going to say multi-thread too much here. We'll talk about multi-thread when I come with that separate threading chapter. We have another one, buzzwords related to Java. The name of these buzzwords is, we have another one, buzzwords related to Java. What is that buzzwords? Called platform independent. Let's come into that. Platform independent, another buzzwords. Okay. Platform independent. What does it mean by platform independent? Let's understand this. Let me tell you, this is another one important features, platform independent, for which Java is dominating throughout the world. Because of its platform independent features. Okay, so what does it mean by platform independent? Let's understand it. Let's understand using some elaborate discussion. Platform independent means operating system independent. Platform independent means operating system independent. Platform independent means operating system independent. What does it mean by this? Okay, so just see here, assume we have three different operating system. One is Linux. In Linux operating system, assume you have installed Java. You have installed Java. So as in Java 8 you have installed. To run Java code inside Linux operating system or Linux OS, you have installed Java. Similarly, we have Windows OS, Windows operating system. The Windows operating system, you have installed Java 8. Similarly, you have Mac operating system. To work on Java, you have installed Java 8. Now see, I told you this Java 8 means Java 1.8, it is called JDK, Java Development Kit, JDK. So if I want to install Java inside Linux operating system, this JDK is different from the JDK that you are using to install in Windows operating system. And this is also different from the JDK that you are using for Mac OS. So these JDKs are different. That means JDK is platform dependent. That means JDK, Java Development Kit, is platform or OS dependent. Platform or OS dependent, because this Java 8 for Linux is different for Java 8 for Windows. You have to install it separately. If you go to the Oracle site, just write here download Java. Download Java 8. Fine. It will give it to the Oracle site. And if you come to this Oracle site, you'll find here, just see here, Linux different JDK, from Mac different JDK, Solar is different JDK, and Windows different JDK. Right? So you have multiple JDKs for different operating system, different JDK you have to download. Correct. So that's why I'm saying here that JDK is platform dependent. Platform or operating system dependent. Whereas Java is platform independent. I'm talking about Java. How it is. So just see here. I'm saying Java is platform independent or operating system independent. How it is. So let's talk about it. So assume you want to compile and run a particular Java code. Assume you want to compile and run a particular Java code, then what should be the sequence of instruction to compile and run? So let me spend some time there, then it will help us to understand much more properly. Now see here, I want to compile and run some Java code. So I have just written one source file, one notepad. I've just written one Java program like hello world.java. I've just written Java source code. This is a simple Java source code. Fine. So what I want this source code I have written. I want to compile this source code. So to compile this, I use JavaC compiler. So using JavaC compiler, I generally compile a particular source code. Fine. So when you compile this, what will happen? When you compile this, what will happen? This hello world.java JavaC compiler will convert JavaC compiler. What it will do? It will create hello world dot class. So from the source code, I got this bytecode. This is called bytecode dot class file. This is called bytecode. This dot class file. We talk about here, then I'm coming there. This is called bytecode. So when I'm going to compile a particular code, I'll get dot class file. This is called a bytecode from this source code using this JavaC compiler. Okay. Now that is compiling that source code using Java compiler, which will create bytecode file. Okay. Now here lots of things is there. Now here after that I want to run this code. If I want to run it, what I have to do? I have to use Java. This dot class file I have to take. This dot class file I have to run. Hello world. Fine. I have to run like this Java and this generated bytecode. When you run, then you will get the machine code or native code. That means this is your hello world dot class file. Now what I'm going to use? I'm using Java compiler. So it is converting this bytecode to machine code. Sometimes we use a term called native code. Native code. Fine. So first we have to compile this source code. Then I have to run it. This step is called compilation, and this step is called run. Fine. So this is how we can compile and this is how I can run. Now see here, when I'm going to compile it, I'm using this JavaC compiler. When I'm going to run it, I'm using Java compiler to run this code, and it will create machine code or native code. Fine. Now here you're talking about different operating system. I'm talking about platform independent. Java is platform independent. What does it mean? Assume let's take it Linux control X, assume control V, assume it is. We have a Windows OS, we have a Linux OS, we have Mac OS. Fine. Now I got in this operating system. See, Java is installed in all the operating system. Fine. So in this operating system, I have compiled this Java code. Java C hello world dot Java. What I have done, I have compiled this code in this operating system, right? So if I compile this in this operating system, I'll get this dot class file here. Hello world dot class. I'll get the dot class file here in this operating system. And what I want to use this dot class file, Control C, in this operating system as well as in this operating system. I want to use this dot class file. So just see, I want to show it like this. Yeah. Now this is the dot class file I got in Windows. Now this dot class file I have copied inside Linux. Same dot class file, the dot class file that I got after compilation in Windows, I've copied inside Linux. I've copied inside Mac OS. Same dot class file. Right now, this dot class file that I have copied from Windows, I want to run it in Linux. I want to run it in Linux. So Java hello world. Compilation is done in Windows OS, running it in Linux OS. Compilation is done in Windows OS, running it inside Linux OS, like Java hello world. And you'll find that it will run fine in different operating system. So that means what? Compiled anywhere, compiled inside this Windows and run anywhere. So compiled in one OS and running in any operating system. Since the Java has these features, that's why Java is called platform independent. Means I can create or compile a project in any operating system and I can run it in any operating system. You can compile it here and you can run it in any operating system. This is the features of platform independent. That's why you call it's a platform independent or operating system independent. So how Java support this concept of platform independent? How? What will happen is that here you are doing the compilation. When you are going to run it in different operating system, what will happen? When I'm going to run it in different operating system, what will happen? See, when I'm going to run a particular code, here we have one JVM. Here also we have JVM. Java I have installed, right? So JVM will be there. Java JVM full name is Java Virtual Machine. I'll talk about it after some time in details. JVM is there. Now, when I'm going to run it, to run this JVM will come into picture. So what will happen? This is that dot class file with the JVM, because if I'm going to run it, that time JVM will come. To run your dot class file, JVM come into picture. So when you run this code, then with the help of the JVM of this operating system, so this is a dot class file, hello world dot class. So this dot class file, with the help of the JVM of this operating system, this dot class file with the help of the JVM of this dot class file with the help of the JVM of this operating system, it will create machine code or native code of this operating system. Again, I'm saying, and I'm going to run it inside the Linux operating system. This bytecode with the help of the JVM of this operating system, it will get the native code or machine code for this operating system. Similarly, if I'm going to run in the Mac OS, I want to hello world dot class. So I'm going to run it inside this operating system. So what will happen with the help of the JVM of this operating system, it will create machine code or native code of this operating system. So this is how this machine code or native code you cannot separate. It is unique to a particular operating system. This is how Java is platform independent. If you compile in any operating system, it will run. If you compile in Windows operating system, you can run it in any operating system. So just see here, like they've given from, I'm talking about this Java code. So if you compile it, you'll get the corresponding .class file, right? And this .class file you can run in any operating system, right? So now here we have the concept of JRE, Java Runtime Environment. I'm talking about it. That is defined inside JDK itself. Java Runtime Environment and JDK, I'm coming into that. So if you compile .class file or bytecode, you can run in any operating system, right? So this is the features of the platform independent. Okay, fine. So this is another one, buzzwords. Platform is very important. Now see that you will say that, what is the advantage? What is the advantage of this concept of platform independent? We'll never copy a .class file from one operating system to another operating system and try to execute. We never do it like this, right? The thing is that what is the advantage? Why I'm saying that this is a very, very important feature, that's why Java, that is one of the important features why today dominating Java worldwide for all the product. Now the reason is that see, Java today, if I'm going to create for your J2E application, for any application, if I'm going to create an web application, web component, how I'm going to exchange data from one server to another server? How to exchange data from one server to another server? How we can exchange data, exchange code from one server to another server. How we can exchange? Assume you have created some web component. Okay, you have created some web component. This web component we always convert it as a .war file. Okay, assume you have created some application component. Let's now talk about application component, right? This application component. So application component is converted as a .jar file. Assume you're working for an enterprise level application, SOA application. Assume you're working on some SOA application. So there we create some extension called .sar, or some extension will come like .mar extension, sar mar mar. So these extensions, what it contain? See this war file for your team have created the project, and your team one of the team is in US, another team is in India, another team in Australia, and they are collaborating with each other. How? They'll exchange the project in Word format. So the team in US for whom the project is running in Word format, and the Indian team, they also got the Word file, and they can execute the same Word file in the operating system, any operating system, and it will run fine. The same Word file, the team who is running in some other country, and it will run in any other platform very well. So that is using these format, Word file, jar file, mar file, sar file, using this extension, you always exchange Java J2E code from one operating system to another operating system. So this is for testing, for deployment, or because we have multiple server, right, in development environment. So whatever you are going to do, we always exchange the code in this format. We never come, so what it contain all the files, .class files, compile java class .class files, compile java class .class files, and some other things also. Compile java class .class files, or some other things also, artifact. So this is how you can exchange the data, exchange code from one server to another server, and it will work fine, it will run fine in different platform, right? So this is how we'll implement the application as platform independent when you work on some project, right? So that's how we say, this is another one buzzwords, platform independent. Another one buzzwords, platform independent. Okay. And another one point is the secure. I'll talk about secure sometime. Let me say some point about this secure. What is the meaning of secure? See, secure is nothing but security. Now, the security can be implemented in our project. Now, security can be provided. We can talk about the security in two major scenarios. One of the scenario is that when you work on some Java program, you will not get any pointer concept. Pointer concept is not there in your Java code. Since the pointer concept is not there in your Java code, from that perspective, you'll find that some of the technical documentation saying that Java code is secure. Another point you'll find, another one scenario you'll find where the JVM is providing security to your .class file. Okay, Java virtual machine. Now, how Java JVM is providing security to .class file, right? So let's understand some more on JVM. Okay,